This is a review and a story of a race that never needed a finish line. A race built on plastic, code, and an obsessive need to print anything. But first of all, how did we got here? It begins with RepRap, the spark that hands the world an open source blueprint and says, go ahead, build it yourself. Prusa grabs that spark and turns it into the i3. Suddenly everyone can afford precision, everyone can improve it, everyone does. Then the world wakes up in 2018, Creality launches the Ender 3, cheap, modable, and the hobby explodes overnight. But the real battle didn't stop there. Color, multi-material, automation. Prusa fires first with the MMU, and then BambuLab shows up in 2022. Fast, polished, brutally advanced, and close code. The next gen multicolor comes as the main scene, AMS, effortless multicolor, and then the entire industry braces itself. Prusa answers with the XL, the punch on the shadows, that show off what was about to start. Creality and all the Chinese brothers, high-speed machines, AMS replicas, lower prices. Snapmaker with budget multi-head systems on a crowdfunding marketing strategy. This is no longer tinkering. This is a technological sprint for quality, for speed, for colors, for the future of making things. Layer by layer, color by color. So welcome to my H2C review. So, the BambuLab H2C. This isn't just another step forward, it's a new category of machine. And somehow, even with my tiny social media presence, I ended up with this print in my hands weeks before anyone else in the world. In fact, I have this print for over more than 3 weeks now. And I've been printing with it for more than 200 hours till today. And the reason for that sits right next to me. The BambuLab Porsche 935 Kremer with this BambuLab livery that resembles the Apple livery that this car had back in the 80s when racing. This is a 9-color CAD model I designed together with BambuLab specifically for this machine. So this video isn't just a standard review, this is the whole complete experience of living with the new H2C. How it prints, how the new Vortex system behaves, how you prepare it, how the Bambu Studio software handles multicolor, how the AMS interacts with it, and even the unexpected bottlenecks that don't come from the printer itself, but from the ecosystem around it. Everything you need to know before you decide if this is gonna be your next printer or your next upgrade for your H2D or H2S. So let's start with the beginning. What is actually like to prepare and bring this machine to life? Setting up the H2C feels instantly familiar. If you have touched any of the H2 series printer, the chassis, the motion system, the internal calibration routines, it all carries the same DNA as the H2D. But that familiarity actually helps, because that makes the moment that things start to change feel even more dramatic. Everything is normal until suddenly the printer reaches the part of the process that no other H2 machine has, calibrating the Vortex system. And this is where the story really starts. The printer calls it the induction hotend rack, but that name doesn't tell you how surprisingly alive the machine feels when it begins. The very first step is almost human. The printer asks you to physically push the small lever on the right side of the toolhead with your fingers. It wants to know the lever's resting position, the inner position it uses to lock every hotend in place. And once you do that, the machine takes over. You step back and the choreography begins. A slim metal rod beneath the Vortex rack lifts upward. The toolhead slides from side to side with this deliberate, precise motion. The rod enters the tiny holes on the side lever, retracts it, releases the lock, lowers again, and then the toolhead glides across every empty slot in the rack. It does this to calibrate the exact position of each hotend slot, 6 in total, remember. Mapping the Vortex system is like scanning a vault. Then, with the hotends installed, it repeats the routine. It moves to each slot, picks a hotend, lifts it, moves it, releases it, picks it up again, testing, verifying, tightening every mechanical assumption it has. And all of it happens so fast that the very first time I watched it, I had to go back into the footage and slow it down. The Vortex system has this kind of reload animation that you get from video games, snapping a magazine into place with the perfect rhythm. And it's happening centimeters from the build plate. It is smooth, fast, precise, and it's unlike anything I have seen on a consumer 3D printer. But the Vortex system isn't the only difference on this machine. On the H2D, we get two LEDs on the front cover. Simple, but effective. On the H2C, that's replaced by a sweeping LED bar, a continuous line of light that animates during nozzle changes. You see this little transition flow across the toolhead every time it swaps between left and right nozzle, giving the machine this futuristic look, almost like it has a personality. This front cover, it's the same one that comes with the H2D Pro. So more than something new, it's an upgrade directly taken from the H2D Pro. When you look behind the toolhead cover, the changes become even more interesting. The right nozzle is now induction heated. BambuLab mentioned coils in their early presentations, and yeah, these coils are here. You can actually see the induction components wrapped around the hot end area, and the heating times are honestly impressive and under the times that BambuLab said. There are small visual changes too. On the heatbed, there is a new label telling you to not place the PI plate onto the bed when the Vortex system is moving. It's a simple warning, but it exists because the Vortex moves vertically and the printer doesn't want you to smash your build plate into the hardware by accident, or even worse, broken your Vortex system. And of course, there are internal mechanical differences when you disassemble the system and start to look at them very closely. The Vortex hot ends themselves are unlike any other Bambu hot end ever released. No cables, wireless, like all the BambuLab hot ends, but these ones are relying on RFID tags for identification and magnetic contact for positioning without the need of using latches. The heated block has a ceramic or rubberized-like insulated area, and the rubberized nozzle tips are completely different size and shape compared to the ones used on the X1, P1 or any previous H2 machine. You even get a full replacement kit of these rubber tips in the box, which says a lot about how intentional this design is. Installing the hot ends into the rack is almost awkwardly satisfying. You align the two small inner holes, the alignment points, with their pins inside the rack. The hot end just slides into place. No latch, no slider, no screws, just magnets. And every time I click one in, I hear a tiny sound, like something inside the rack engaged electrically or magnetically. Maybe it's electromagnetic retention, maybe it's just the mechanic of the alignment pins settling, or maybe it's the Vortex servo keeping the home in position. But whatever it is, the system feels clean, fast and ultra easy. This might be the fastest swapping system that we got on any consumer printer right now. Once all the hot ends are installed, 3 in the upper rack, 3 in the lower rack, plus the 7th already in the left side of the toolhead. The printer immediately updates the UI with detailed information on each nozzle, nozzle size, status, placement, and even temperature. And during testing, I noticed that the small motor responsible for operating the Vortex racks looks suspiciously similar to the size to the extruder stepper motor that BambuLab uses in the H2 series or in the P2S. Maybe it's the same part, maybe not, but the scale suggests a shared lineage hardware. With the racks installed, calibrated and fully mapped on the H2C, now it's time for what comes next. And that's where the real bottleneck appears on this machine, and it has nothing to do with the own machine. So the next step is setting up the AMS units, and this part is absolutely critical because it's here where I found the only genuine bottleneck in the entire H2C experience, and it has nothing to do with the printer's capabilities. It's about where you place your AMS and how long your PTFE tubes are. And to let you see how important the AMS is for this printer, BambuLab will be offering only the H2C with an AMS2 Pro as they told us. Unlike any other H2 or BambuLab printer, it's highly probable that this printer will be only sold with an AMS2 Pro unit and not as a standalone product. When the printer arrived, it came with a 4-in-1 PTFE tube, and I had 2 AMS units available, the AMS2 Pro that arrived with the machine and an older AMS1 that I already owned. But the moment I started my first test print, a carbon fiber 3D Benchy of my own design, the issue became obvious. The print itself was simple, 2 colors, but I purposely forced the machine to use only the right nozzle to swap hot ends in the Vortex system, just to see how the entire mechanism behaved. And here's what I saw. The toolhead will finish a hot end swap, move into position over the flashing tower, reach temperature almost instantly, and then it will just sit there, waiting. At first I assumed this was caused by the induction heating system not actually being at temperature yet. But I checked the screen. The nozzle was already hot, but the printer yet wasn't moving. Then what was happening? The AMS was still retracting or feeding the filament through the long PTFE tube. The Vortex system was so fast and the induction heating so fast that the printer was actually waiting for the AMS to catch up. It wasn't just a few milliseconds, it was a few seconds. When you extrapolate that over tens of thousands of swaps on a long multicolor print, those seconds become hours. Hours that you are wasting just waiting for filament to travel through a tube. This is the key reality of the H2C. The Vortex system is in most of the cases faster than the AMS. Even the AMS2 Pro can be slower than the Vortex if your tube is long enough. And the AMS1, well, it's even much slower. This means the speed of your entire multicolor workflow depends on how close your AMS is to the printer, how short your PTFE tubes are, and which AMS model you use. This can extrapolate to any other multicolor printer, but the fact that here is that you are not only paying for a system that saves money and time on purchase, it also does on color swaps. So to use its full advantage on speed, all you need to do is to consider the AMS placement and the length of the PTFE tubes. If you want the full 7-color capability, you will need to use 2 AMS units. Ideally 2 AMS2 Pros, placed close to the printer, but if you are like in my case where you will be using an AMS1 and AMS2 Pro, remember that the nearest AMS to the printer should be the Mark I AMS. Remember this because it's a defining part of the whole H2C experience. Various AMS are not an extra, it is a must-have for this printer. After adjusting the AMS placement, all I had to do was to send my first real print through Bambu Studio. But before we get into the slicing logic of the nozzles or the filament grouping and all that, let's take a look to what Bambu Studio asks you on the printer to do first. When you load a multicolor model into Bambu Studio for the H2C, everything feels familiar, until the moment you assign colors to nozzles. The left nozzle must always hold only one filament. That's just how the system is designed. The right nozzle, however, will hold everything else. And with the H2C, everything else means up to 7 possible hot ends. So Bambu Studio first groups colors into the left nozzle or the right nozzle, the same way it does for the H2D. But then you see a second layer of logic, assigning each filament to one of the Vortex hot ends. This is where things get interesting. If your print uses 7 or fewer colors, the system stays simple. Each filament gets its own hot end. No purging, no contamination, 0 waste, except the tiny cleaning purges at the start of the print. But when you go over 7 colors, as I did with the Porsche car, the slicer groups multiple filaments into the same hot end in a way that reduces cross-contamination as much as possible. It studies the color transitions in your model, identifies which colors are least likely to contaminate each other, and clusters them into single hot ends so that the purging is minimal and so the cross-contamination. And on the pre-release version of Bambu Studio that I had, everything worked unsurprisingly well. You can manually override assignments if you want, but realistically, the slicer is nearly always right. And customizing them usually adds more purges and more times. Once everything is set, the slicing is done, and the print is sent to the machine. That's when the real experience begins. The sensory experience of watching the H2C work. And the experience, it's something entirely new. When the print starts and those Vortex swaps begin happening in just a few seconds, the hot end being released, the lever retracting, the tool head sliding into a slot, picking up a different hot end, locking it, move it back out, you feel something that most 3D printers didn't give us in a very long time. Wonder, mechanical curiosity, excitement. It feels like the first time you ever saw a 3D printer move or a tool head swap system. But this time it feels like watching a new kind of engineering unfold right in front of you. Not a tool changer moving an entire tool head, not a nozzle cleaning itself between swaps, something different, something smaller, faster, tighter, and honestly cooler to my eyes. But that emotional rush is only half the story. The other half comes from the numbers and the results. And the numbers tells a very different story when it comes to what multicolor printing is on this machine. This is where the H2C stops being a curiosity engineering and it becomes something far more significant. It's a machine that changes entirely the economics on 3D printing and the economics of multicolor printing too. Because the moment you push beyond simple 2 or 3 color prints and you begin exploring 7, 8, 9 or even more colors, the difference between the H2C and every traditional single nozzle multicolor system or even the ones built it with multi-tool heads, times and waste gets exponentially increased compared to the H2C. To understand how dramatic the gap is, we need to talk about the print that pushed this machine to its entire limits, far more than I've ever pushed any printer ever before. The BambuLab H2C. This wasn't a random test model, this was a 9-color, large-scale, fully detailed print, created specifically to test the limits of the H2C. And the numbers it produced were honestly shocking. The total filament used for the entire print, including supports, poops, purges, flash tower and all structural material, was 1,806 grams. Out of that, 838 grams went directly into the model itself, 304 grams into supports, 131 grams into purge waste, 532 grams into the purge tower. Let's isolate the important part. 131 grams of purge waste. And for a model that uses 9 colors, that's nothing. That's the kind of waste you expect from a small 3-color print on a traditional system, not a huge multi-component 9-color project. In percentage terms, the H2C wasted under 10% of the material on purging in this model. And keep in mind, we were over the 7 hot end ideal limit. This system was forced to reuse hot ends and push multiple filaments through the same nozzle, yet the waste still remained incredibly low. Now compare that to any single other AMS single printer out there. If I had printed this on a single nozzle printer, the total purge waste alone would have been 2,646 grams. That's more than 2.5 entire spools thrown into the purge bucket. We're talking about $30 to $60 worth of filament literally disappearing into piles of rainbow spaghetti. And the difference doesn't stop at the filament. The time savings are equally dramatic. On the H2C, this car printed in 5 days and 19 hours, but on a traditional multicolor system, this same 9-color model will have taken significantly longer. Not just hours longer, but potentially a full week longer. The difference in efficiency is so significant that if you were a printing farm printing everyday multicolor prints, you will be paying this printer in about 3 or 4 months maybe. And that's only with the cost savings on time and filament. Even if you only print a multicolor model every 2 or 3 days, the reductions in waste and the time efficiency stack up incredibly fast. And let's say this is not an average day print. What if we go with more simple multicolor prints? The Koenigsegg Jesko parts I printed, specifically the rims on one build plate with 3 colors, or the front bumper and the skirts in another build plate using total 4 colors. These parts fall into the more normal range of multicolor printing. Even here, the numbers speak loudly. The rims weighed 103 grams total. On a single nozzle AMS printer, they will produce 28 grams of purge waste. On the H2C, almost no waste at all, because no purging was needed. The difference in print time was also striking. On a single nozzle multicolor printer, those rims took 6 hours and 40 minutes. On the H2C, they took 4 hours and 40 minutes. A full 2 hours saved on a small 3-color part. What about the front bumper and side skirts? Those parts weighed 160 grams total. The P1S wasted nearly 100 grams just in purchase, almost as much waste as usable material. Meanwhile, on the H2C, that purchase waste disappeared entirely. And this wasn't even a 7-color print. This was a simple 3 or 4 color job, the kind of work most people will do far more often than massive 9-color projects. Even here, the H2C delivered economic savings in time and filament. But to truly understand what 7 colors means on this printer before we hit that 7 ideal limit, I printed something else, the Albert Einstein and Oppenheimer's Funko style miniature. This wasn't a model I sculpted myself, it began as an AI generated concept using Google's Nano Banana system. I sent that to concept to MakerWorld's MakerLab tool, which automatically converted it into a 3D printable multicolor model. This model used exactly 7 colors, so that means that this didn't need any purchase of any kind, only the ones that you have to make at the start of the print. On a traditional multicolor printer, this tiny figure, 61 grams of actual model material, require a staggering 475 grams of filament in total and 1 day and 10 hours of printing time. That's what purging does. It turns a 60-gram figure into a half a kilo of filament movement. On the H2C, the print should have finished in 15 hours, but I made this print using sport mode, so it was in 11 hours. Total filament use 157 grams, and from that, no single gram was used for purges. So we saved more than 300 grams of filament and almost a full day of print time. On a model that fits in your hand, when you look at these numbers together, the patterns become almost impossible to ignore. The more colors you use and the longer the print goes, the more exponential the savings will be. This is all I can say about the new H2C. It's a whole different way of thinking about multicolor. The H2C isn't fighting the old rules of purge-based multicolor printing. It's bypassing them entirely. This machine makes multicolor feel accessible. It makes it feel reasonable. It makes it feel fast. Not something you plan on your week around, but something you can actually use in your daily printing workflow. The Vortex system removes the punishment from multicolor printing, and when that punishment disappears, everything changes. This is why I think we are entering a new phase of competition. Because the day this video goes live, BambuLab is presenting the H2C at Formnext, the biggest printing event of the year, and Prusa has already teased multicolor solutions of their own. Other companies will absolutely follow. The entire industry now knows that 3D printing in multicolor is not anymore a toy or a gimmick. It's the next thing that people will expect on their printers, not only on expensive printers like this one, but also in budget printers probably in the future, like we have already seen with all the advances in the 3D printing industry. BambuLab didn't just launch a new punch, they rewrote the rules of the fight. This is not the end of the race, but the beginning of a new one. A race where the only question left is how fast the rest of the industry will catch up. And the future right now is going to be a little bit more colorful. So thanks so much for watching this review. This is all I can tell about the new H2C. There's still more things that we need to cover more deeply, like some results in different styles of prints, but this was based on a pre-release version of Bambu Studio. This printer also had a pre-release version of software, so probably in the coming soon videos we will take a deeper look to how the results are in this new printer. So subscribe to the channel if you like this video. There's gonna be probably more reviews coming soon. If you wanna get all these cars that I design and that I uploaded for free to MakerWorld, yes, you can follow me on MakerWorld at Mr.RodDesign, and nothing more to say, just stay colorful.